Okay, so today we are going to interpret the phase diagram of an isomorphous system, right? So this is basically a very typical isomorphous phase diagram. You can see over here that it forms something like okay, a three phase only. Okay, you have liquid on top, and then separating between the liquid and the solid, you have liquidus line, and in between you have a phase of liquid plus alpha, and finally you have at the bottom right, you have alpha or the solid solution. So to interpret the phase diagram, the first rule that you need to remember is number and types of phases. If we know the temperature and the composition, then we will know the number and types of phases present. Okay. For example, okay, at point A, point A is located over here. Okay. Given that at point A, the temperature is at 1100 and the composition is actually at 60% of nickel, 40% of copper. Okay, so point A, what will be the phase? Okay, so I think yesterday I have briefly told you that any things or any points that I think lies between this region, the blue region, it will be exist as alpha or solid. So that is why over here it mentions that, okay, at point A, okay, the phase that it will exist is actually alpha. So you only have one phase. Okay, so next we have point B. So point B is located somewhere here at the range of white range. I mean, inside the white range. Okay, the composition is at around 35% of nickel with the remaining of 65% of copper and at the temperature of 1250. Okay, so here you see that it is actually inside the range, I mean, of liquid plus alpha. Then you will have two phases, liquid plus alpha. So this is actually a so-called a mixture, mixture phase. You have liquid and also you have solid. So I forgot to tell you also that if you have 0%, okay, 0% of nickel over here, I told you yesterday that this will be 100% of copper, isn't it? Okay. And then when you have 100% of nickel, it means that you have 0% of copper. So let's say that if I ask you what will be the purity or the melting temperature of a pure copper, okay? So the melting temperature, okay, it can be read over here. 100% of copper is actually equals to 0% of nickel. Then you will see over here, this is actually the point that separates the solid and between the liquid. So you have a solidus line. So this is actually where the melting temperature is, Tm. Okay, it's around 1100 or maybe less than 1100. So this will be the melting temperature of copper, because beyond this temperature, it's already in the green region, which is liquid. Okay, it's already been molten and become liquid. Similarly, if I ask you what will be the melting temperature of 100% nickel, okay, so you will see from here, this is where, okay, the region or the solidus line or the phase boundary between the solid to liquid. So you can read from here that this is the melting temperature of nickel. So at around maybe 1420, for example. And this one probably like 1080 degrees C. Okay, all right. So moving on to the next rule, the composition of phases. If we know the temperature and composition, then we will know the composition of each phase. So this actually quite easy. Okay, for example, okay, you have initial composition, a studied composition at 35% of nickel. 35% of nickel. Okay, 35% of nickel over here. You just draw a straight line, straight vertical line over here. And at temperature A, TA, TA is located here. So point A. Okay, so what will be the phase? Sekejap. Check ada tak yang menunggu. Yes, 5 people are waiting. Right, so Aina Ifah. So what will be the phase for point A?
Liquid.
Liquid, okay, right, good. So liquid, quite clear, liquid. And then in this case, in this rule, it says that if we know the temperature and also the initial composition, so C0 is actually the initial composition, then we can know the composition of each phases. Over here, it mentioned that at point A, at temperature A, phase is liquid, and you will see only liquid that will present, only one phase that will present. So the composition of Ca, let's say I say this is A, so the composition of Ca, okay, it will be the same as initial composition, as. So it will be 35% of nickel. Okay, why it is similar as initial composition of I think point A? This is actually because of it exists as one phase. So remember, if you have one phase, okay, so the composition okay will be similar as composition initial. All right, okay, so let us check at point D. Point D, okay, so this is point D at 35% of nickel and at the temperature of D. Okay, so you will see that this is actually at the phase of alpha or solid. All right. So what will be the composition of D? Okay. So similar things, once you identify the phase, and since over here we detect that point D only have one phase, then composition of D is actually equals to 35% of nickel. Still the same. 35% of nickel, because as I said, over here, if you have one phase, then the composition, okay, as will be equals to the composition of initial. Okay, all right. So now we are going to the most difficult part. If you have a mixture, let's say at point B. Okay, so point B, what will be the phase? Sekejap, let me ask. Balkis apa ni?
Both liquid and solid phase.
Liquid and solid. Okay, Balkis Hanani, thank you very much. So you have at point B, okay, right? So the phase is liquid plus solid or liquid plus alpha. So how many phases? Berapa banyak phase? Balkis? Satu ke dua?
Dua phase.
Dua phase. Okay, so remember, if it is a mixture, L plus alpha, so it means that you have two, so don't count it as one because you have two different phases, liquid and also alpha. Okay, all right. So another thing that you have to remember in this rule is that if you have two phases, okay, so the composition will be equal to two compositions. So you have C liquid and also C alpha. Okay, so over here, I think when we report CA, point A, composition is equal to 35. This is actually at CL. C liquid because the composition is totally 100% of liquid. And at point D, this is actually C alpha because 100% of solid. So meanwhile, at point B, you will have to report both composition of liquid and also alpha. So how to do that? Okay. So you'll see that point B is located somewhere here. Okay. And you will see that this is actually the phase boundary. Okay. Liquidus line and also solidus line. Okay. Right. So what you need to do is you draw a straight line. Did you see this line? Okay. Okay. So you just draw the line that touch the end of liquidus line. Okay. So you just drag it down. So this will be the composition of liquid. And another end, if you drag it down, you get the composition of alpha. Okay. So meaning that at point B, okay, composition of liquid is actually equals to 30% of nickel. Meanwhile, for alpha, okay, if you drag it here and then you'll see that for composition alpha is equals to 43% of nickel. So remember point B, since you have two phases, then the composition you need to report two, Cl and also C alpha. Okay, faham tak? Is it clear? All right. So moving on to the next one. This one is slightly tricky. Okay. Rule number 3. Weight fraction of phases. Okay. So if we know the temperature and also the composition, then we will know the amount of each phase given in weight. Okay. So for example, initial composition is 35% of nickel. Okay. So still at the same composition. At point A, okay, so since, as I said, point A, you will have 100% of liquid, meaning that you only have one phase. So 100% liquid, okay. So it means that WL, the weight fractions of liquid is equals to 100%. Okay. So you don't have, you have 0% of solid because totally everything inside here is liquid. Point D, okay, still you have one phase, which is alpha. It will be 100% of alpha or 100% of solid. Then the weight fraction, pecahan berat is actually W alpha is equals to 100% of solid. So no liquid is actually exists here. Right. So how about point B? Okay. So since point B, we know that you have two phase. Okay. Then you know also the composition, you have two. You have composition of liquid, you have composition of alpha or solid. Then you also need to report both weight fractions. So you have a weight fractions of liquid and also a weight fractions of solid alpha. Okay. All right. So how you are going to calculate that? How you are going to calculate the weight fraction? Fraction is actually pecahan lah. I mean, it is actually a total of 100. So let's say that if you have 100% of materials, so how many percent are actually exist as liquid? How many percent are actually exist as solid? Okay, right. So I think I told you earlier that you can actually draw the line. Okay. So you draw a line over here, one here. I think maybe I need to use another color. Maybe I use purple. Okay. Another one over here. Okay. So you have one half actually from 35 percent of nickel until it touch the liquidus line. Okay. So this actually your composition of liquid. And another half is actually your composition of alpha. Okay. And since you have divided the two lines, okay, one half and another half, so you can actually name it. So over here, we name it as line R. R. So if you ask me why it is R, actually it doesn't matter. Nak bubuh apa ni elephant also no problem. If you want to put banana, nak bubuh apa-apa simbol saja no problem. It's just actually to differentiate the fraction. Okay? So you have, for example, R line over here, and another half is actually S line. R line actually from C naught that touch to liquidus line, and S line is actually from C naught to solidus line. Okay? All right. So what to do next? Okay? Next, we are going to apply this formula. Okay? So this formula is named as lever rule. Lever rule. Okay? Lever, lever dalam bahasa Melayu maksudnya baji lah. Okay? Fraction. Okay? Right. So let's say if you want to calculate the weight fractions of liquid. Okay? So where does liquidus or liquid phase exist? So liquid phase actually exists at the top left. Betul tak? Dia dekat atas sebelah kiri. So you actually see that liquidus line exists and on your left. Okay. Meanwhile, for solid, okay, actually it exists or it shows that the region is at bottom right or right lah, dekat sebelah kanan. So if you want to calculate weight fractions of liquid, you must actually calculate the fraction on the opposite side. So meaning that liquid is on your left. Okay, so nak cari weight fractions of liquid, you have to actually look at the line opposite it. So it will be, opposite line is S lah. So S over R plus S. And then for solid, if you want to calculate the weight fractions of solid, you have to look at the opposite line. So solid dekat sebelah kanan. Okay, so opposite line of alpha is actually R. Okay, so R over R plus S. Okay, so this is actually the formula that you are going to use to calculate the weight fraction. Okay, so W liquid or weight fractions of liquid, S. So how to calculate the S value? Over here, you already read it as 43. Okay, right. So it will be 43 minus 35 over R plus S. So R plus S is actually the total length of R and S lah. So 43 minus with 32. Okay. So you get actually the answer is equal to 0.73. Okay. Right. And for W alpha, weight fractions of solid. Okay. As I told you, we are going to use this formula R over R plus S. So R, what is R? R is actually 35 minus with 32 divided by 43 minus with 32. So you will get 0.27. Okay? All right. So in exams, if you are being asked to calculate weight fraction, please write the answer in decimals. Okay? Don't write it as percentage. Okay? If it is asked in percentage weight fraction, then only you will multiply with 100. Otherwise, you just give the value in decimals, in fraction, 0.73 or 0.27. Okay, so another thing that you can also use for lever rule, it is known that WL plus with W alpha will be equals to 1. Let's say that you already calculate WL, the weight fractions of liquid, you already get it. So in order to calculate W alpha, okay, you just simply subtract it. So 1 minus WL. Then you will get W alpha. Or I think in written also, no problem. Okay. All right. So level rules, okay, as I told you, the sum of a weight fraction WL plus W alpha is equals to 1. It is actually the conservation of mass. So the total of a initial composition is equals to the fractions of liquid and also fractions of solid. Then that is why you have W liquid multiplied with composition of liquid plus with W alpha multiplied with composition of alpha. Okay, so if we combine above equations, then you will get the formula that I told you. So for weight fractions of liquid is equals to S over R plus S, and for alpha it is equals to R over R plus S. Okay, right. So the reason why we use level rules, why we need to calculate the opposite side. Imagine that you have apa tu, some things lah. Okay, you have a person. Okay, dia naik, kita panggil macam jongkan-jongkit lah, seesaw. You don't know what is the mass over here. Not sure what's the mass, but you have a load. You have a known load. Kita tahu kita ada beban kat sini. Okay, so if you put the load over here, that finally it balance out. Okay, the two fractions, then okay, the weight of this thing is actually equals to the load that makes it balance. So this is actually the logic why we use the level rules. Okay, alright. Ada soalan? Any questions so far? Anything? Okay, kalau tak ada, saya nak tanya soalan. Okay, alright. So you can look at this example, example 2. Determine the phases present, the composition of each phase, and the amount of each phase in percentage weight. Okay. For the following: magnesium sulfate, okay, iron sulfate, leusolide at 1600 degrees C. Okay. So this is actually the given how to say, the given phase diagram. Okay, so the question actually asks, determine first. So you have different things over here. You have to read what will be the composition, amount. Amount, it is actually equals to weight fraction lah. Okay, of each phase. All right, so at 1600. So A, you have at the composition of 20% of iron silicate. B, at 50% of the composition of iron silicate. And C, at 90% composition of iron silicate. So saya nak someone to try lah. I want someone to try this. Gary, are you there, Gary? Gary Tian.
Yes, sir.
Okay, all right, Gary. So I want you to do A. First, I want you to determine what will be the phase, okay, of A. Okay? And then after that, find what will be the composition, and finally the weight fraction. Even though I think you can see the answers there, but try to think, because I think phases is also not been mentioned there. Okay, all right, Gary. Okay. So for B, okay. Irsalina ada?
Ada, Doktor.
Okay, all right. So Irsalina, can you try for B? Okay, look at 50% of iron silicate. I want you to determine the phase. Fasa dulu the phase first, and then after that composition, and finally the weight fraction. And then lastly, okay, the last one, Kamala. I think Kamala, I called you yesterday. You are not there. So today, are you here?
Yes, Doctor.
Okay, all right.
Yes,
So I
Doctor.
want you to do C. At 90% of iron silicate, please find out what is the phase, and then the composition, and finally the weight fraction. Okay? All right. So maybe not long. I just give you 1 or 2 minutes. All right. Maybe we can go first with Gary. Gary, have you find out the phase? Gary, are you there? Or still trying?
Sorry, doctor. My line is kind of bad. Can't really see the screen.
Okay, all right. So never mind. At 20%, so over here, I think I have helped you with the dotted line. So first, it is mentioned that the temperature is at 1600. Okay, so you just draw the horizontal line. Okay, 1600. Okay, and then I think for Gary, 20%. So 20% from here. So this is actually your point. 20% of iron silicate at 1600. So what will be the phase? Gary, did you see it?
Yes, 100% solid.
What's the phase?
Solid.
The phase. Okay, never mind. I guess maybe Gary have some, I think, connection problem. So this one at point A, maybe I just name it as point A. Okay. At 20% of iron silicate, 1600 temperature, the phase is at solid or olivine. Okay. Right. Then what will be the composition? Okay. So the composition will be what? This is actually one phase. So the second rules in the level rule, it says that if you have one phase, then the composition will be equal, okay, to the initial composition. So over here, C alpha is equals to 20% of iron silicate. Right? So finally, what is actually the weight fraction? The amount or the fraction. And over here, we know that you only have one phase. So the fraction that we are talking about is only W alpha. Okay. So W alpha, it will be 100% solid or 100% olivine. Okay. Right. So now, Irsalina. Irsalina, dapat dah habis?
Yes, doctor. For the phase, it is liquid and solid at
Okay.
1600 temperature degrees Celsius. I mean.
Liquid plus alpha. Okay. Composition?
50%.
50%. Really? If you refer back to the level rules, it mentioned that, I think I have told you that if you have two phases, that
Oh,
means that you need to report the two composition as well. So you will have
using
C
the formula, is
alpha
it?
and also C liquid. Agak-agak tu berapa?
For alpha, it is 38%.
Alpha 38.
Yeah.
Roughly lah Okay. I think 30% is somewhere here. So it should be like around 28 lah. So this is 40. 30 is somewhere in the middle. And this is actually 20. So I just put like 28%.
Okay.
Liquid?
100.
100? Tak faham lagi kot. Okay. Alright. So over here, I think I've told you that it is actually in liquid plus alpha. So you have to report the two phases or the composition of both. alpha, and also liquid. So how to do that? So where is actually your solidus line? So this is actually your solidus line. Okay. And where is your liquidus line? Liquidus line is at the top, on the top. Okay. Right. So you drag the line over here that touch your solidus line. Then this will be your C alpha. And when you drag another line that touch your liquidus line, okay, so this is your CL. Okay, so your CL, it should be like around 65%, for example. Okay, so this is actually your composition of point B. CB is equal to C alpha 28, CL 65. Okay, then how you are going to calculate the fraction? Yang ni Idina punya dia complicated sikit. Okay, so since you know that at point B you have, okay, oh kat sini saya tulis 63 So this one should be 63 and this one 29. I put 63 and 29. Okay. Right. So what will be the weight fraction? Okay. So since it is a mixture of two phases, okay, so you have to report as well the WL and also W alpha. Okay. All right. So you can actually name the two lines, the tie line. So let's say we call it as R and S as well. Okay. So R and S. Isalina, solid dekat sebelah mana sekarang ni? Sebelah kiri
Kiri,
ke sebelah kanan?
kiri.
Kiri. Okay. So kalau nak cari solid, kita kena tengok yang tentang dekat sebelah mana. Line apa? R ke S?
Dekat R ke doktor?
Okay, solid dekat sebelah sini kan? Nampak tak?
Mhm.
Olivine ni solid. Okay, dia dekat sebelah kiri. So saya beritahu tadi, okay, if you want to calculate the weight fraction, so you have to look at the opposite line. So opposite line solid tu dekat sebelah kiri. So opposite line dia apa? R ke S?
S.
S. So S. Over R plus S. And then untuk liquid dekat mana pula? Kiri ke kanan?
Kanan.
Kanan. Kita nampak dia dekat sebelah atas kanan. So kanan. So kanan, tengok line yang bertentangan adalah line apa? R. R over R plus S. Okay, right. So S. How to calculate S? S is actually 63 minus with 50 divided by 63 minus with 29. Dia cakap in percent. Dekat sini percent. Then you have to multiply with 100. Then you will get the answer is equals to 38%. So L, okay, liquid, weight fraction of liquid. Liquid opposite line is R. So R, what is R? R is actually 50 minus with 29 divided by 63 minus with 29. Then you will get the answer is actually equals to 62%. Okay? All right. So just now when we explain the level rules, we are looking at this phase diagram. And now we have an example that the phase diagram looks like a mirror image of what we have studied just now. So I put the question here. Can you spot the difference between the two phase diagram? So this one that we looked previously, and this one is the one that we are looking now. So the reason is actually, okay, each phase diagram, it will show a different behavior. Sometimes you can also have like reported as 100% of iron silicate, or sometimes you can be, the graph showing 100% of magnesium silicate. So that is why we have a mirror image of this phase diagram. Then, if you want to calculate the weight fraction using the lever rules, then it will be in opposite as well. Okay, but the most important thing kalau nak selamat, remember the one that I've told you. You just name it R plus S, but for example kita tahu kat sini, solid is actually located at the bottom left. Then the opposite line will be S over R plus S. Liquid located at top right. Then the opposite line is R. Okay. So Kamala.
Yes, doctor.
Okay. So you got for the last one, C.
Yes.
Okay. So
I got
90% is somewhere here. Okay. What will be the phase?
liquid phase.
Phase is liquid. Okay. What will be the composition?
Composition will be similar to initial one, so 90%.
Okay. So it's going to be C what?
C liquid.
C what again?
90%.
Cl, because it is at the liquid. So over here, if it is 100% of solid, then it will be C alpha. Over here, Cl, then it will be 90% of iron silicate.
Iron to silicate.
Okay? All right. So what will be the weight fraction?
100% liquid.
So W?
WL equals to 100% liquid.
Okay. Thank you very much, Kamala. Very good. Okay. All right. So another one, another set of question. Okay, so we are given here copper nickel phase diagram, and you have point B. Point B at 65% and at the temperature of 1250. What will be the mass fraction? Mass fractions of liquid and also the mass fraction of solid. Ini ada seorang lagi terkeluar. Okay. Anyone would like to try this one? Yeah, okay. I think okay, so I called someone who's not here yesterday. So Melody Lim, I think she contacted me yesterday. Hi, how are you? Are you here today?
Yeah, I'm here.
Okay, all right. So point B, what is the phase?
Solid and liquid.
Okay, solid and liquid, because we are looking at here, 35%. Okay, here is actually 35%. And then at 1250 over here. Okay, so it is actually at alpha plus liquid. Okay, so what will be the composition of liquid and composition of solid? Yes, still you the same person, Melody Lim.
Yeah, I'll wait.
Just give a approximate value. C liquid. Okay, got it or not?
Oh,
So composition of alpha.
alpha 40,
40?
43.
Okay, maybe 42 lah.
Okay.
And then
Liquid
for
31.
okay, sorry, this one 31%. Okay, all right, Final question, what will be the weight fraction, W alpha and also W liquid? Oops. So you have R and S. So alpha is solid is here. So opposite line is R over R plus S. And liquid is over here. So opposite line is S. So R equals to 35 minus with 31 divided by 42 minus with 31. S 42 minus with 35 divided by 42 minus with 31. Okay, so you will get the answer later. Okay, is it okay, Melody Lin?
Yes.
Okay, all right. So over here they give the composition is equal to 42.5 and composition of liquid is equal to 31.5. So you will get the value like that after that. Okay, all right. So probably the last slides for today before we end our lecture. Okay, I hope everyone have understand the basic concept of reading the isomorphous phase diagram and also how to determine composition, weight fractions, phase, and whatsoever. Okay, so if you have problem, then you can come back. So remember, on Friday we are going to have a quiz. I will test you how you can read the phase diagram of an isomorphous system, how to determine the weight fractions, and how to determine the composition and whatsoever. Okay, so the last slide for today is basically on the microstructure. Okay, so since we are talking about isomorphous system, I told you in isomorphous system, in order to produce the alloy, first thing is that we melt the element together until it becomes liquid, and after we mix, it will be solidified, okay, to form the alloy. So in microstructure, microstructure is actually the morphology, the structure of the element at different phase. Okay, so in isomorphous system, the cooling process in order to solidify the molten liquid could be done either by equilibrium cooling or non-equilibrium cooling. So for today, maybe we just look at equilibrium cooling. So what does it mean by equilibrium cooling? Equilibrium cooling, it means that in order to solidify the alloy, the process of cooling will be done slowly, which means if you have mixed the molten liquid together, you just let the mixture to cool off or to solidify naturally. Okay, so since this is a very slow cooling process, then it actually maintain the phase equilibrium. Okay, all right. So consider 35% of nickel and the remaining of copper cooling diagram from 1300 degrees C. Okay, so from 1300 degrees C and at 35%. Okay, 35% of nickel at 1300. Okay, so what will be the microstructure at different points? So point A, you have point A, point B, point C, D, E. Okay, so all these actually exist at the different phase. Point A exists as in a liquid phase, totally liquid. Okay, so at point A, you will see that completely liquid, no microstructure, because when it exists in liquid, it doesn't form any granules, any grains, solid grains. So you cannot see anything. So it will be clear. The microstructure will be clear. Okay, composition will be the same as initial. L is equals to 35% of nickel. Okay, point B. So now point B, it is located at the phase boundary of liquidus line. Okay, So the first solid alpha begins to form at liquidus line. So it's still giving the same composition. Composition is still 35% of nickel. But over here, okay, the microstructure that you can see is that it start to form a small grain. Okay, nampak the biji-biji kecil ni. Okay, so this small grain is actually the first solid that's, start to form. Okay, composition of liquid is still the same, 35, but the composition of solid, it is equals to 46. So how do you know that it is actually equals to 46? So point B over here, okay, it is at liquidus line. So that is why Cl is still equals to 35 if you drag it down. But for C alpha, if you drag this line, it will actually show you the value of 46. Okay. All right. So point C, still at liquid plus alpha. Okay. Composition of liquid and alpha phase are 35%. Sorry, 32% of nickel and 43% okay, of nickel. So since I said if you have a mixture, you have to report both. So for liquid, you have 32%, okay? And then for solid, you have 43%. So what will be the phase diagram? The microstructure. So the microstructure will be this. You will see that the alpha grains start to become bigger as compared to the previous one. Previous one was little grains. Now it becomes slightly bigger with the composition of alpha is equal to 43. You read it from here. Liquid now become 32, no longer 35. Okay. Right. Point D, still at alpha plus liquid, but it is actually at the phase boundary of solidus line. Okay. Right. So solidification start to occur. Composition of liquid and alpha phase are 24% nickel and 35% of nickel. Right. So now it is located at solidus line. Okay. So composition of alpha is equals to 35. Okay. And composition of liquid is now equals to 24. And the grain is starting to become even bigger and start to meet with each other. Okay. And finally, you have point E. Okay. Point E, it will be totally in 100% solid. So this one, actually the microstructure, it will form a so-called polycrystalline alpha phase. Okay. With the composition of nickel equals to 35%. Okay. Right. So for the microstructure, okay, it is also one of the important things that you need to remember for the phase diagram. Okay, so since today we are looking at equilibrium cooling, so you have to remember what will be the drawings. Okay, if let's say that you have the composition or the phase at liquid, liquid fast alpha at different stage. Okay, and finally at solid, total solid, what will be the microstructure? Okay, right. So I guess for non-equilibrium cooling, we are going to continue this on Friday. But as a homework, okay, I want you to draw, okay, the microstructure of all these point at point A, B, C, and D and E, okay, at 35% of nickel. So I'm going to post an event in your e-learning, okay. I will give you 1 day lah to complete, to draw, okay, the microstructure at different points. So let's say that you don't know, you can still refer to your notes. But what the things that I want you to learn is that how to train. How to memorize the microstructure of different cooling step. Okay, right. So I guess maybe I will start the event today and deadline will be tomorrow. So before we end our lecture, is there any questions so far? Anything that you want to ask regarding on microstructure or anything related with the level rules? Ada soalan ke? Okay, so if there's no question, then I will adjourn our class for today. So thank you very much for your kind attention. I hope that whatever you have learned today, you are able to understand. And if you don't understand, please come back to me quickly so that we can have another set of exercise. Right? So thank you very much, class, for your attention. Hope to see you on Friday, 11 a.m. And with that, thank you very much and have a good day. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Raka.
Yeah.
Welcome.